Hello everyone, welcome to this channel ML Guru. In this video, we will use all the concepts which we had learned to build a simple end-to-end machine learning project. And the dataset which we are going to use is this one, which is titled Real Estate Price Prediction. I will give this link in the Jupyter notebook as well. So in this, let's have a look at the data. So there are 8 columns. The first one is just the index, the second one is transaction date, the third one is house age, the next is distance from the nearest MRT station, then the next one is I think it's the number of convenience stores nearby. The next one is latitude and longitude, and the last column is uh, the price of the house per unit area. So let's begin. So first you have to create this working directory. Now don't worry about all these files, we will see this one by one. The first thing is create a new Jupyter notebook in which we will train our model. So for that we will import some libraries. So all these are the basic libraries like pandas, numpy, seaborn, matplotlib, then sklearn's model selections, then pre-processing in which from which we will be using the standard scalar model for feature scaling, then as you know the polynomial features, then the linear model which we will be using to fit the dataset is the ridge model, which uses the L2 regularization loss, and then pickle to save and load our trained model. So let's run this cell. I have also given the link to the dataset, so you can download the dataset from here. The next thing is I have already downloaded the dataset, as you can see here. Now let's read the CSV file into pandas data frame. So here it is. Now as you can see, this is the same dataset which I had shown you while we were discussing the feature scaling. So the pre-processing steps are the same. So as I had told in previous video, we don't need this first column. The second column from x1 to x6 is the x dataset, and the last column comes in a y dataset. So we separate x and y. The next thing which we have to do is splitting of the dataset. So we will use the train test split module which we had imported from sklearn model selection, and then we will split it in and we will keep the test size as 0.25. Now remember, we are splitting the dataset into two parts. The first part is the training dataset, and the second one is the validation dataset, which we had discussed in theory. We will use this validation dataset to monitor the training of our model, or in short, we will select the model. We will select the best model based on the performance of that model on our validation set. So after splitting, you can see there are 310 data points in X and 104 data points in 310 points in training dataset and 104 training points in validation dataset. Now we have to convert the Y column, which we had split it into Y train and Y well into numpy array. So we can now currently it is in pandas data frame. Okay, so we can convert it to numpy array by simply to numpy function, and the shape of the Y is Y train is 310 rows and 1 column. Now the next thing which we have to do is adding polynomial function. for which we must specify the degree of the polynomial which we want to fit on our dataset. So I have randomly taken this phi. We will in this video I will also discuss how we do hyperparameter tuning to select the best model. So for now I am just writing any random number, so let's take 5. The next thing is we have to create the object of this polynomial feature which we had inputted from sklearn and give the argument degree which we had declared here. The next thing is to fit this object on our training dataset. So we create a new variable xtrain poly, and this is equal to poly.fit transform xtrain, which means we will fit as well as transform the xtrain. And once we have trained this poly object on our xtrain, we can now use it to transform the xval, and we will save that array to xval poly. So after doing that, as you can see, initial there were I think just 5 columns, but now when we have added polynomial features of degree 5 to original x, we have got new features, and now the total count of the features are, the total count is 252. Alright, then now the next step before training is to feature scale our data. That is very important, as we had discussed in previous lectures. So we will create an object of the standard scaler and we fit it on this xtrain poly which we had just created here, and then we using that fitted object we will transform our both xtrain as well as xval. Okay, you could just do fit transform as we had done here, but as I had told you earlier, there are two methods. You can either use fit transform or first fit on train and then transform both your xtrain and xval. So I have demonstrated both the methods here. So now the training data as well as the validation data has been scaled. Now let's look at the first 5 rows of the train scaled, and as you can see, after doing the feature scaling, it has converted the pandas data frame to a numpy array, and that's why we had also converted our y column to numpy array, because we are not scaling the y, so we have to separately convert it to numpy array. So these are the first 5 rows. As you can see, they are scaled such that the mean is 0 and the standard deviation is, or sorry, the variation is 1. So now we are finished with the data pre-processing part. Now we will start the training part. So for that we will import this rich regression model from sklearn's linear model from here, and this rich regression is used for implementing linear regression with L2 loss, which we had seen in the previous lecture, and it takes the parameter alpha, which is the same as lambda of the regularization loss, which we had seen in the previous lecture. The higher the value of alpha, the higher is the regularization effect. If the value of alpha is 0, there is no regularization. Okay, so for now we will just input any value, let's say 10, and we will create the object of this rich regression module. You can look at the details of this rich regression in sklearn's documentation. You will see the loss function which was implemented. It is same as the L2 regularization loss. So we have created this model object, and now we will fit this object on our x train scaled and y train. So let's fit it. It takes some seconds, and we are done with the training part. And now let's look at the training score and the validation score. This score which we get by model.score is nothing but the R2 score. Uh, it ranges from if the model is perfectly fitting, it will be 1. and it can also take negative values, which denotes that it is badly fitting the data. So now we will first look at the training score, which is 0.67, and the score on validation data is 0.71. Now here we have taken any random value, like we have taken the value of degree to be 5 and the value of alpha to be 10. But how do we know which is the best value of degree and alpha? So for that, what we do is we do hyperparameter tuning. Now first let's understand what is the difference between parameter and hyperparameter. So the parameters are nothing but the weights, the W1, W2, W3, which we had seen. And that parameter is learned by the model from the data. But these hyperparameters, which are the degree, the value of alpha, these values we give externally to our model. So these are called as the hyperparameters. So we will try different values of degree and alpha, and we will do a grid search, meaning we will try all the possible combinations of these, and we will choose the one which performs best on the validation data. So for choosing the degree, we have chosen 10 values from 1 to 10, and for alpha we are choosing 4 values, namely 0.01, 0.1, 10 and 50. You can choose more values as well, but initially I am choosing these 4 values from 0.01 right up to 50, and I am storing this in a dictionary. So I have declared it. Now instead of writing all these steps, initializing the model, then training, using the standard scalar, polynomial fitting, instead of writing all these steps again and again, I am writing a function to do it. And I will write this function in such a way that I will use it for fitting uh, the model on data given the value of degree and alpha, as well as for hyperparameter tuning. So the arguments which this fit function takes is the x train scaled and y train on which our model will be fitted, the x val scaled and y val for validation purpose, the value of degree, the value of alpha, and the last two are for hyperparameter tuning. So by default I have set it to false. If this grid search is true, which means I will be doing hyperparameter tuning, and the last argument is this experiment. Why? Now as you can see, we are trying multiple combinations of these degrees and alpha. So each such combination is an experiment in itself. So each combination will be given a unique experiment name. So, but when we are not doing this hyperparameter tuning, we don't need this experiment name and all. So I have by default set it to none. So initially what we do, given the value of degree, we will create the polynomial features object, and then we will fit it on this x train and we'll transform the x val. These are steps, all these steps are same what we had done here. Okay, I'm just writing it inside this function. Then we do the standard scaling part, and then we fit the model, the ridge regression model, which takes the parameter alpha, which we give in the input. Next, it will calculate the training score, it will calculate the validation score, and then if grid search, this means if I have said this grid search is equal to true, then what it will do is for each experiment, it will create a list in which the first value is the experiment name, the second value is degree, third one is alpha, then training score and validation score, so that I maintain a record of all these values for each experiment, and it will return these scores. But if I'm not doing experiment or hyperparameter tuning, I'm just using to fit the data given the value of degree and alpha. For that, I just want to know the training score, the validation score, and it will return me the model, the trained model, the polynomial object which we had used here, because inside a function it is a local object, but after training I have to use it to make predictions on test data. Okay, so I will be needing this polynomial object as well as the standard scalar object which was fitted here. All right, so we will define this function, and this tqdm is nothing but now we will do this multiple combinations. Okay, so to keep track of the progress of the experiments I will use this tqdm, and the way to use tqdm is we will see in a bit. So first what I'm doing is I'm creating this empty list named result. It will store these values for all the experiments. Now initially the first experiment name id is 1. So for I in range, so we have to use this tqdm outside the range. For I in range, so first I will loop through all these degrees, and for each degree I will try each value of alpha with a single degree. So the outer for loop is for degree. Then we will get the value of degree from this dictionary inside this variable degree. Then for each degree we will try all the values of alpha. We will store the value of alpha from this dictionary inside the variable named alpha. We will create an experiment name. The experiment name is experiment plus the experiment id, and after each experiment we increment the value of experiment id. And as you can see, we append in this empty list the value of this fit function, and what all arguments we are passing, this the x train, y train, x val, y val, the value of degree and alpha which we get from here, these combinations, and we set the value of grid search to true. The experiment name is equal to experiment name which we are just creating here, and uh, the fit function will return this score which contains the experiment name, degree, alpha, training score, validation score, and we will append it in this result. So as you can notice, the result will contain multiple rows corresponding to each experiment. Now let's run it. Okay, we have missed this cell. All right. So as you can see, we have printed out this result. Each row corresponds to a single experiment, but this is not looking pretty good to visualize. So what we do is we convert this list into a pandas data frame. So for doing that, we use pandas.pd.data frame, in which we pass this result, and the column names are experiment id, degree, alpha, training score, and validation score. And then we visualize this pandas data frame, and it will give a nice tabular form. But now we have to select the one which performs best on the validation data. As you can see, uh, there are two ways to do this. First one is we will plot a graph. So for plotting the graph, what we will do is we will initialize the pld.figure. I will give it the title as R2 score because we are monitoring the R2 score. So we will use this pld.plot. What are we plotting? The training score and the validation score. So we will plot this train score column as well as the validation score column. On x-axis, I want the experiment names. So I will do this by plt.xticks, and I will pass this experiment names by uh, first I have to give the indices. Okay, so uh, okay, let's first see the graph and then you will understand this code much better. So I'll run this first. So this is the graph. The one in the line in the orange color is of the validation score, and the line in blue is of the training score. And on x-axis you can see it corresponds to each experiment name. So on x-axis, to print this name, what we have to do is we have to, for each indices like 0, 1, 2, 3 on x-axis, we have to set a corresponding string. So the left part is of indexing. We do this by list of range of the length of the result df, meaning the number of rows in this training data. The right part is the value of string which we want to print over there. So it is given by the experiment id column, this column of this result df, and rotation is equal to 90. And I have set the y-axis limit from 0.5 to 0.9. It depends on you. If you want to zoom into some portion, you can do this by xlim and ylim. So let's do this. So from this, what I can see is the maximum value of this validation score. I think is somewhere around here. I think this one. So this one is experiment number 31. But sometimes it is very hard to visualize it and determine the best experiment. Okay, so for that, what we will do is we will sort this result df according to values of this validation score. For doing that, we'll do this result df dot sort values, and in the argument, the first argument is by. So by what values you want to sort? So we want to sort it by this column. The column name is val score, and the second one is ascending is equal to false, means I want it in descending order. So let's run this, and you can see the experiments in the descending order of val score. So as you can see, the best experiment was experiment number 31, in which the value of degree was 8, the value of alpha was 10, and the train score was 0.69, validation score was 0.78. And you can see the first, second, third, fourth. Okay, so what you can do after this is, now you know that the best value of degree we got is 8 and alpha is 10. So what you can do is you can again run this experiment. Where is the parameter? Here it is. So now you can more fine tune it by setting the degree, let's say 7, 8 and 9. We are zooming in the best possible solution. Okay, and the best value of alpha we got was 10. So now in the alpha list you can put values like 6, 8, 10, 12, 14. You are basically zooming it, and you are fine tuning to get more accurate values of degree and alpha. But I leave that to you. I'm doing just one level of hyperparameter tuning. So uh, I have printed here the first column in the sorted order, which means the best value is this experiment number 31, and I will use these values to train my model. Now I'm training the model on selected hyperparameters. So I will call this fit function. I will give this xtrain, ytrain, xval, yval. I will give the degree as 8, alpha as 10, and the last two parameters are by default false, which means I am not doing hyperparameter tuning. In that case, it will return three values: the model, the polynomial object, and the standard scalar object. So let's run this. We get our training score and validation score, and we have our model, polynomial object, and standard scalar object. Now the next thing to do is we have to save these three objects, so that in future we don't need to train again and again. We will use these train objects to make predictions on unseen data. So for saving purpose, we can use pickle or you can use joblib. I am using pickle. So from pickle I am importing dump, and here I am dumping these three objects, which is the best model, the polynomial, and the standard scalar. The way to do is that open, we have to give the name. So I am giving the name as best model dot pickle. This extension is of pickle in right binary mode. I will do this for all these three objects, and after doing this you will notice that you get the saved values over here in your project directory. So I have this best model.pkl, poly.pkl, and here is the scalar.pkl. And once we have saved, we can load it again for making predictions on new data. So for doing that, we use from pickle import load, and the way to load is using this load function and opening this saved file in read binary mode. So we open all this file. You can give any names here. So we have loaded it and we are ready to deploy. Before that, let's use these loaded objects to take inputs from user and giving the predictions. So for that, I have defined this prediction function. I have also done the same thing when I was explaining the multivariate linear regression. You can watch that video. I will explain this in short. So I am taking one by one the values of house age, the distance from the nearest MRT station, number of convenience store, latitude, longitude from user one by one, and I will save it in this list. Then I will convert this list into NumPy array, and I am adding this extra list so that because the model expects a two-dimensional array, but this was just a single array. This one is just a single array, single L. So I am adding this extra dimension so that it will be of the form row and columns. And then I'm applying this polynomial object to transform. Then I'm standard scaling it, and then I will return the output, which is the model.predict. In predict function, I have to give the input, which is this one scaled array. And since as I told you, it is a two-dimensional array, so this the indexing is to go inside the first array. This next indexing is to go inside the second array, in which the value of the prediction lies, and we are rounding off to 2 digits. Okay, now I have taken some sample values from our dataset to make predictions. And one thing to note is we cannot use any arbitrary values for these particular inputs, because if you go inside this Kaggle, you can see that all these columns have a particular range. For example, let's say the latitude and the longitude. So you can see the data for which this model was trained was such that the values of latitude ranges from 24.9 to 25. So while testing also, it must come from the same distribution, as well as for this longitude. Okay, you cannot enter something like 30.5 because it is not in this range. It will give, the prediction will be very bad because the model is trained for this particular distribution of values. Alright, so for that purpose I have taken these two rows from our dataset. So let's predict first for this first row. So the house age is 19.5. The second value is this. Third value is 9. The longitude is this. And you can see the prediction given by our trained model is 45.19, whereas the actual value was 42.2. So it's not that bad. It is pretty good. Now let's try on the second set of values. The first value is 13.3. The next value is 561.98,450. The next one is 5. The next one is this much. And the value of longitude is this. And then the predicted value by our model is 45.57, whereas the actual value is 54.8. So it's not performing that perfect. Why? Because see, there are various models available. We are just using the polynomial regression model, because we had learned that, but there are various regression models. You can also use neural network. Neural network gives the best accuracy because uh, it has more complexity, so it can fit the data very well. Also, there are other regression models like XGBoost regressor. There is also SVR, which is the support vector regression. So you can try all that values. But since we have only covered the polynomial regression till now, I am using this polynomial regression model. Alright, so the training part is done. The next thing is I created another notebook here in which I am just loading all these three train objects, and the same function is here just to make predictions which we had seen here. So if it works here, meaning you are ready for deployment. Now for deployment purpose, what you have to do is you have to create a Python file. I'll open and show you. Alright. So in this Python file, we are basically creating a web app, okay? And we are using Flask to build the web app, the web API, okay? So the first of all, you need to pip install this Flask, this flassger, and all the other models which you don't have. This flasker is for creating UI, because as a data scientist, we usually don't have that much knowledge on front end. So this flasker helps a lot in creating automatically. It creates the UI so that we can use it. So let's see how to use this flasker. So first, from Flask we need to import Flask and request. We import this numpy and joblib just to uh, actually we don't need this joblib because we are using pickle to load the models. The next thing is to import Flasker. From Flasker we need to import this Swagger, and from pickle import load. So you can use this basic structure, and you can modify it according to your project. Okay, so first thing which you have to write is to name. We have to create this app object from this Flask. Next we have to call this Swagger on this app. Now these three lines are to loading our model which we had just seen. Then we have to create this app.root. So by default there is only slash, so this is the default page, and the method is get because we have to get the values of the attributes from user. In this we have to define this predict function. So the this doc string which you see here in triple quotes, you have to write this as it is, just you only need to change the values inside it. So first one is the title, which I am giving as house price prediction. Here you can write the description of your project, okay, and then we have to give the information about the parameters which we want to take from user. So the first parameter is the first thing which we have to specify the name of the variable. So the first one is house age, and we are taking it as a query. The type of this is number. Now number includes integer as well as float, so I am taking it as a number, and here you can write the description, and required is equal to true. Now I do this for all these inputs, and you have to write a response is equal to 200, description is equal to the output values. Now we can write this function which we had defined. We have to modify it just a little bit. Now let's say I have to take the first value from user. The name of that is house age, so I have to get it by request dot args dot get inside the bracket house age, and uh, we don't need to print this. This is just for debugging purpose. Okay, so we store the value of house age inside I1. We append it to L, and then we continue. We do this for all the attributes, and finally we convert it to numpy array. Then we use the polynomial to transform it, then scaling it, and then the same thing to give the prediction. And I'm storing the prediction in P, and we have to return this outside the function. I'm returning it as a string. Okay, and at last we have to write if name equal main app dot run. I'm saving it. Now first let's run it locally. So for that, first let's go into my virtual environment in which I created this project. So activate. The name of my environment is GPU test. You have to enter. If you are using Anaconda, you have to enter the name of the environment which you are using, and then I need to go to this directory. Inside that, I will run this Python script which was named app.py. Now it will give you the local host link where you can see the web API you created. So we go over here, and uh, after this you have to write API docs, and you can see you will see this UI created by this Swagger which we had used. So you click on this get, you click on this try it out, and here let's check it. So let's enter the age 19.5. I will use the same values which we used here. I think it will be nice if you write in the description the range of value which you have to enter. You can look at the range from here. They have given the range for example, house age. The range in the training data is from 0 to 43.8. So you can specify in the description for each variable that you have to enter the values in this particular range. Alright, this was 9. The value of this was, this was our latitude, and then the longitude. Also you can the best thing I think is to create a slider or something. You go to their github account of this Swagger. You will find all the documentation. You see how to implement the slider, the drop down menu, all those things are there. And let's execute this, and you can see you get the response. The price of the house per unit area is 45.19. Now we are able to do this thing locally. Now we have to deploy it we have to host it such that other people will be able to use it. So for that, first of all you need to create this GitHub repo. And as you know, when you will host this model, uh, you have to first create that environment. For example, while running locally, I am using this environment in Anaconda. So it has specific versions for, let's say, sklearn, pandas, numpy. Okay, so this particular model will run in this particular fixed versions only. Why? Because we have trained on that particular versions. So to host it, first the server needs to be created such that it will use the same version of sklearn, pandas, numpy which we have used to train it. So for that we have to create a file called requirements.txt. As you can see here, it will specify the versions which we are using. Now we don't need to create this manually. What we have to do is there is a, a library called Piprex. So first you have to import that. So let's see how to do it. So first activate your environment. Sorry, activate GPU test. That's the name of my environment. And then you do pip install pip rex. Now you can see the requirement is already satisfied because I've already installed it. Now what you need to do is you need to go to your working directory. Since we have created uh, all these things in our Jupyter notebook, but this piprex reads only .py files. So what I have done is I have created this Python file. In this I have just uh, copy pasted all the libraries which we had used while training. So this is one part. Also we have this app.py in which we have imported some other modules which you can see here. We have imported this many modules, so this is already in .py file, so we don't need to do this again. So I have this two Python files which contains the imports which we had used. Now we have to go in this directory and we have to do pip rex. What it does is uh, all the .py files inside our working directory, it will convert the requirements.txt for that particular project only. So it will take some time. Okay, so you can see that requirements.txt file already exists. If you want to overwrite, use //force. I will not do it. If you are doing it for first time, you will get your requirements.txt. Okay, so here is my requirements.txt. And before uploading it to GitHub, you need to add two things over here. First, uh, actually there is a bug in the latest version of sklearn. It will give errors when you deploy it. So instead of this 0.23, you use 0.22. Okay, and the second module which you need to add here is, okay, before that you need to create another file known as this proc file. In this you have to just write a simple line, web gunicon app colon app. So uh, if you change the name of this file, you will get an error. So uh, ideally keep it same as what it is here, and do not rename this app.py, keep it app.py itself. And we have to import this gunicon by doing pip install. So what you do is you do pip install gunicon. I have already installed it, and you need to get the version of that. Okay, so what you do is you open the Python terminal and you just to import gunicon, and to check the version of this you do gunicon dot version, or otherwise you can add this import gunicon inside that this file which we had created here. Okay, so that the piprex itself will give the version. As you can see, the version is 20.0.4. So I'm copying that. Let's go here inside the requirements.txt. We'll add gunicon equal this much. Alright, after doing this, what you need to do is you have to upload this inside your GitHub. repository. You have to create a new repo. Inside you have to add the proc file. This is a very important file. Then I have added the CSV. It's not necessary. Again, you have the training notebook. This is also not necessary, but uh, I'm adding this into repo as a part of project. So I'm adding all these files which I had here. But inside this, the main files are this app.py, this bestmodel.pkl, poly.pkl, then requirements.txt is necessary, scalar.pkl, and this proc file. These are the important ones. Once you do this, you go to Heroku. If you are a new user, you create your account and then you go here to create new app. You have to create write your app name. So I am writing house price prediction ML Guru. So this app name is available. You keep this region United States only. Don't change it. And let's to create app. Now here, what you need to do is connect to GitHub. And here, I've already linked my GitHub. You can link here, and you have to write the name of your repo. So my one is house price prediction. So I'll write here house price prediction and search. So you will get here. You need to connect to it. Okay. Now there are two options to deploy it. One is the automatic deployment, means when you commit to a repo, it will automatically deploy, or you do it manually. I am doing it manually for now. So I will do this deploy branch. Now as you can see, it will install all those necessary libraries which we mentioned in the requirements.txt. See, it's downloading all those modules. It is creating that environment so that our model will not throw error due to version issues. It will take some time. And one thing which I forgot to tell you is you download this Heroku CLI. You can use it when you host your model. Suppose if the model throws some error, you can view those logs using this Heroku CLI. So you go here, you download that exe file, then from CMD you can use that. I will show because I have already installed it. So suppose you missed some library inside the requirements.txt and you don't know which one is that. So you can look at the errors using this Heroku CLI. You can view at all those logs and change your GitHub repo accordingly. So our app was successfully deployed. Now let's view it. Again, you have to go to slash API docs. So here we are. We do get and try it out. And again, the thing which I had mentioned you to add the description, I have added it inside this GitHub repo. So see, I in the description I have also given the range of the values which you have to uh, type. So here was our app. So let's say the age is 30. The distance is, let's say, 100. The number of convenience store is, let's say, 5. Let the latitude be 24.9.95 and the longitude be 121.50, and let's execute it, and here you get your predictions. Okay, now the last thing which is remaining to show is how to use that Heroku CLI. So you open your CMD. I by mistakenly opened Anaconda. Open your command prompt, type Heroku, and then logs, then slash a, then after this your app name. The app name is house price prediction ML Guru. It's copy that, and then slash slash tail. So here you can see all those logs, all the requests you get uh, on your server. So if your model is throwing some error, you will get to know from here, and you can correct your files accordingly. Okay, so that's it in this video. Hope you liked it. I will give the link of this repo and all those things in the description box. Okay, hope you liked it. Thank you.